Hello and welcome to this PV Tech Talk webinar in conjunction with GoodWe. This webinar will explore how GoodWe's ESG2 series inverter can provide energy autonomy for homeowners. My name is Sean Roach and I'll be your host for today's webinar. Joining me is Andrew Tyler, Regional Manager for Sub-Saharan Africa at GoodWe. Andrew's presentation will explore how GoodWe's hybrid inverter operates to maximize PV-based savings, as well as new features of its hybrid inverter and how it addresses the requirements of residential customers. Before we start, though, a bit of housekeeping on my end. Today's webinar is set to last around 45 minutes and will include opportunities for audience questions. You can use the dialog box on your screen to submit those questions during the webinar. The webinar is also being recorded and will be available on PV Tech later today. But without any further ado, I'll hand over to Andrew.
Good morning, listeners. Thanks so much for the introduction, Sean, and extremely excited to have the opportunity to present to the audience our new latest and greatest ES Generation 2 series inverter. Those of you who've dealt with, installed, resold, whatever it might be, GoodWe products in the past would know our ES product was one of our sort of defining products in terms of market growth. And I think the Generation 2 will bring some really exciting new features. All right, let's get started. So looking at a system diagram, those of you who've previously used our ES Generation 1 will be familiar with this. But just to, sort of inform the audience that maybe haven't had this opportunity, the main benefit of a hybrid inverter like our ESG2 would be to, number one, use various sources of power. So you'll see on the, single line diagram in front of you, we've got solar power, we've got battery power, and then we've got an energy meter, which has a CT clamp attached to it. And that allows you to do, firstly, zero feed-in, as well as load monitoring. And what that also allows is to split the load. In countries or markets where backup supply is a requirement, you will not need to connect the entire backup of your home through the inverter. You can split those loads into what we call essential and non-essential loads, and still getting the benefits of solar or battery power being provided to those loads through the non-essential supply. And then, of course, the GM1000 meter with our CT clamp will stop the power from exiting the grid. And for those markets where export limiting is welcomed, you can, of course, switch this feature off, but it does sort of come in an all-in-one box, which is a great solution for that. In terms of combination, so again, if you're familiar with the products, you would have known, from the Generation 1, we had an ES series and an EM series. We also had the SBP series. That's not our focus today, but I will touch on that. You'll note that both the ES and EM series have combined into a single series, which we call the ESG2, but it is denoted by two different part numbers. So the EM series, which has the smaller backup circuit, maybe preferential for European markets, or those markets that don't need backup supply necessarily. It will have an M in the part number. So for the 5 kilowatt example, you would see the part number as GW 5000M-ES-20. And then for the higher backup capacity ES product, you would see a similar part number, just with the M missing. And that would mean that a 5 kilowatt inverter has a 5 kilowatt backup. So it's a much higher capacity backup, which might be more suited to your markets that have, common grid failures or load shedding, as we know it's well in South Africa. The SPP series stays the same. The part number does change from the Generation 1 to Generation 2. You'll see it just adds the -20 at the end, and then also the S moves to in front of the BP after the dash. That SPP series is just an AC coupled or AC retrofit version of the ES product. So that wouldn't be a full hybrid. That would be an AC coupled where you are coupling to an existing grid-side system. In terms of features, we really pride ourselves on having a product that's easy to install and also has a plug-and-play design. What we mean by that is it's a product that has external connectors you normally using a proper AC connector, a proper battery connector, and MC4s for your PV connections. So it's very familiar, very easy to do. It's the only way that you can ensure that the connection is correct. When you're using just an open terminal block, you may not screw it in correctly. There might be a loose connection, and that does take a little bit more time on site. So we prefer to have this plug and play design. In terms of commissioning, those of you who've used GoodWe before would know that our commissioning, in my opinion, is one of the easiest on the market. We use an app for commissioning on our hybrid inverters. It is the PV Master app, which is available on Apple and Android stores. And it's really as simple as a multiple choice questionnaire, choosing what mode you would like to operate in, choosing the battery, the number of batteries, and then a few other settings, but nothing you can really get wrong. Multiple choice, the sort of answer is in front of you, and that's what I think makes it quite easy. It also has a very aesthetically pleasing design. So it's got a mutant soft style, it's got a soft arc, and it also pairs really well aesthetically with our Lynx Home battery series, which you can see on the right. These products are also extremely quiet. You'll note that we mentioned less than 30 decibels. Although the inverter, the larger 6 kilowatt, does have a small fan for internal heat, rotation or dissipation, this is still extremely quiet and can be installed, in a sort of commonly used area without much issue. There are, with fans, you would have a challenge putting it in your lounge or in a place where, you want your friends and family to see, but this does fit into the home really well and also looks, really aesthetically pleasing. And then also we do have an integrated PV DC isolator, which, depending on which model you buy, you would be either isolating 1 or 2 MPPTs. The 3 kilowatts in our range has 1 MPPT. The 3.6, 5, and 6 have 2 MPPTs. Then looking at a comparison on a like for like, so we're comparing on the left our old generation 1 GW5048D-ES to our new generation 2 GoodWe 5000-ES-20. Apologies, we seem to have just gone into load shedding. Perfect timing for a webinar on a product that it supports this kind of issue. So just excuse while the backup system kicks in. So if you look at the the comparison, we've highlighted a few important features. The first would be looking at the maximum DC input power. So you'll note that on the previous generation, it was about 1.3 or 130% DC oversizing. On the generation 2, we've got 150% or 1.5 DC to AC ratio. So that means that you can, for 5 kilowatts, connect up to 7.5 kilowatts of PV panels. That is something we'll discuss later on as a feature, and exactly how it works or how it's applied. Then just below that, we've got the input current per MPPT. The older generation was an 11 amp MPPT, and obviously as the module market has moved on from smaller modules and gotten sort of bigger every couple of months, it seems, you end up either having higher voltage or higher current modules, and more commonly is higher current. So to have a 16 amp MPPT on the new generation really does cover quite a significant portion of the modules, probably up to around, say, 460, 500, 520 watts, somewhere around there, depending on the model. It's only really the large utility scale panels that may not be suitable, that sit at 18, 19 amps. Then with the backup output, I think, for those markets that have things like you've just seen, load shedding kicking in, having a large backup capacity is important because you'd want to connect, as much load as possible through the backup without constantly having shutdowns. You'll note that the max continuous output power when grid is available has basically doubled. So you can, with a 5 kilowatts inverter, power up to 10 kilowatts of load on the backup side with the grid supporting that load. And we'll look at that in more detail a bit later so you can sort of see a real world example. And then the last two points was protection. So with the surge protection, we previously had type 3 on the DC and AC side. We've upgraded the DC surge protector to be a type 2, while the AC surge protector remains a type 3. And then for those markets, I know there are some markets in the EU or in Europe that require AFCI or arc fault current interruption. This is something that can be, purchased when the channel partner or whoever purchases the device. They can request that AFCI is installed as a feature, but we make it optional. For certain markets, it's ideal to have it, and for some markets, it would be an extra cost for no specific benefit. And then with communication, we previously would have a Wi-Fi or a LAN module. Typically, the inverter would ship with a Wi-Fi module. And you had the option to replace that with a LAN. With the new device, we've got Wi-Fi as standard. You can also use our new combined Wi-Fi and LAN module. And then, of course, for those markets where we have 4G available, the 4G dongle can be used as well. And one other thing just to highlight, I think, especially when it comes to residential installations, the lighter and the smaller the inverter, the better, I guess. You've normally got very tight spaces to fit these devices in, and also it makes it easier for, one or two guys to install the device on site. The new device is around 6.5 kgs lighter, and in terms of dimensions, it's quite a bit sort of flatter, or it has less height, I guess. Right, going into the key features of the new generation 2. Some of these have been improved, some are completely new to this generation. Firstly, parallel or paralleling of the system. What this allows you to do is to, start off with a 5 kilowatts, and if the customer would like to upgrade at a later stage, you can parallel a second 5 kilowatt to bring your total system size to 10 kilowatts. That would be 10 kilowatts on the backup circuits as well, not just on your grid connected loads. Typically, how this would be done is you've got a master device that is, controlling the entire system. Your energy meter and your CT clamp, as well as your smart communication dongle, are connected to the master, and then your slave inverters are connected to the master via RS485. Three pieces could be paralleled, so you can build up to a system of 18 kilowatt with our 6 kilowatt, or obviously slightly smaller if you look at any other of the inverters sizing. And then you'll also note that you would use a DC bus bar for your batteries, and then of course parallel the connections for the AC output as well. Another new feature, and something I think which really looks to the future with regard to GoodWe's approach, is looking at load control or smart load management. This example is a device like a hot water tank or a heat pump, or in South Africa we call it a geyser still, where you've got a load that you don't necessarily need permanently, but that you would want to switch on under certain conditions. So via software integration, you'll see on the right of this the slide, there's a screenshot of our app. You've got a load control section, and you can choose different ways, either doing it via timing. So you could say, at 5 o'clock every day, switch it on, at 6 o'clock, switch it off. And you could also do backup load control too, such as setting when you would like the load to switch on or off based on a battery state of charge level. And the way this works is we've got a dry contact in the inverter, which is depicted by the yellow dotted line or dashed line, and from there it will essentially send a signal to an ATS or an auto transfer switch that will switch either on or off based on what we've specifically set. Then a more, a similar example, but yeah, we're talking about having, a specific load on the backup circuit. Typically, when you have a load on your critical load or backup output, it would drain the batteries, but maybe it's important, for you to have this type of load still connected to the backup, but with the ability to control it based on our smart load control. So yeah, same concept, a dry contact to an ATS, except the load is on the backup side. So you can still, use your normal critical loads with only this critical load of less importance, or your hot water pump, hot water tank rather, can still switch on or off on the backup circuit based on how you've set it up via our software. And you'll see a visual representation of what we discussed earlier, which was having the the ATS open on a specific SOC level for your battery. And then of course you've got a certain percentage reserved for critical loads, which in essence, if you reach that state of charge, that dry contact will send the signal to open that ATS so that it's no longer pulling power from the batteries. Microgrid integration. So this is also quite a new feature with the ESG2. Typically you might have a customer who has a existing grid side PV system installed, and they now want to add some battery capability. Whether it's to do some energy arbitrage, or potentially because they need some backup for grid outage conditions. What this allows you to do is to connect a ESG2 or even our SPPG2 to the a grid side inverter. The grid side inverter will be connected to the backup circuits of our inverter, and via frequency shifting, the inverter is able to tell your grid side inverter how fast or slow to produce power or to charge the batteries. So you'll see on the graph on the right, we've got your SOC level, which is starting at flat and going to full. And then it also depicts the charge time slowing down or stopping completely. And you'll notice that when you've got a very open frequency, such as starting from the left, the inverter will be charging at full power. And then when you are talking about seeing the battery level reach 50%, for example, the frequency actually starts to go up to maybe 52.5 hertz or 62.5 hertz, depending on the market, and that will then slow down the charging. And once that frequency goes to, for example, 55 or 65 hertz, then the grid side inverter will stop producing power completely. So it's quite an intelligent way with being able to control the grid side inverter without having necessarily a complete GoodWe's solution. So if you have another brand grid side, it's not a problem. The control is done through grid frequency, not through RS485 or Wi-Fi or something else, which might require the same brand on both products. This is a big one for our customers on the African continent. I would say, generator integration is unfortunately a requirement in most cases. Normally if you're running an off-grid system, or maybe you've got a extended power failure or grid outage, you would typically want to use a generator to maybe top the batteries up for emergency reserve. And we've got in the left example, we've got the option to send a signal to a relay to switch our generator on or off, depending on a specific software setting. So we would typically say if our batteries reach a 20% state of charge, we would then start the generator to top the batteries up. And typically you would have an ATS or an auto transfer switch installed, that when the grid does fail, your ATS changes over between the grid and the generator to then charge the batteries. And then on the right, you also have a option to do it manually. So you can have a manual changeover switch between the grid connection and the generator. And if you want to top up your batteries, you would manually start the generator and then change that changeover switch from your grid to the generator, and it would then top up the batteries. So there are both options. Maybe you don't want to have auto control because you don't feel like it's the best option. You can have a manual option in this scenario. Operation modes, those of you who've used GoodWe's products before would be quite, familiar with these. The names have changed somewhat, or will be changing, going forward. We've got our self-consumption mode, which is what the product was designed to do. That's to maximize self-use of renewable energies, whether it's solar or solar charged batteries, to provide power and therefore saving on your electricity bill. We also have time of use, which is quite beneficial for those markets that have time of use tariffs, where you would have power that's more expensive during peak hours per kilowatt. Per kilowatt hour, and then you've got periods where the power is cheaper. So you would typically set your batteries to charge during cheaper electricity cost time, and do the exact opposite during more expensive, which would be discharge your batteries to the load. And then outage support. This is really a backup mode, which is typically and more commonly used, for my markets in Africa. And what that does is it keeps the battery at 100% state of charge unless there is a power outage. So it's really a backup UPS style type system, but with the benefit of having some solar charging and solar powered loads. And then lastly, typically not something that's necessarily used for your residential type, customers, but something that we're implementing in all of our products, so definitely worth having a look at, is peak shaving. So, this you often when you have a system, and typically with commercial systems where there is a period where if you exceed a certain amount of demand on your electricity supply, you would get charged more for that month of electricity. But again, it's not necessarily something that's looked at for residential type customers. Communication. So this is quite a nice way of looking at it, and we've definitely grown, the possibilities with our products. It's just starting at the bottom. We'll see the 3 dongles that we spoke about earlier, which is Wi-Fi LAN, 4G, and those can be interchanged by just simply clicking out and clicking in. So as a distributor, it's quite important to obviously carry stock of these. And then starting from the left, you'll see local monitoring and commissioning, as we said, is done either via Wi-Fi or Bluetooth and using one of our apps. We then also do remote control and monitoring via our GoodWe's server. And that GoodWe's server would be the SEMS portal as you know it. And then we also are able to monitor via our web platform or app. We then also have an option for installers that have a lot of our products and want to use their own platform to use an API, using by sending data or rather pulling data from our platform and displaying it on your own. And then we've also got Modbus RTU, Modbus TCP/IP, and Sunspec, which allows you to use a third-party meter or controller if you'd like. But we, as I said earlier, we do have that included in the box, a GoodWe GM1000 meter anyway, so it's not necessary. And then the IEE 2030.5 with our smart dongle is a requirement for our American customers, but something that we don't see typically in the EMEA region. And then just the general, view on the data storage from our product. So the actual inverter stores data for up to 7 days in case of a network breakdown. So typically, if a system loses Wi-Fi or maybe the Wi-Fi router runs out of data, then you can upload. When the inverter does reconnect to the internet, it would upload that data. So it's quite nice because you don't want to lose the data just because of a network connection that was down. And then our data is stored on our server for greater than 5 years. And with the standard warranty of 5 years on our hybrid inverters, that's the reason for storing that for up to 5 years, so that there is some historic data in the event that you need to view that. Safety. So on the left, we've got lightning protection. So as we said, you've got type 2 on the DC side and type 3 on the AC side. These are integrated into the product, so aren't interchangeable. But what we do have, which is a new feature to this product, is an SPD alarm. So we're able to see on the SEMS portal via an error code that the SPD has been tripped or used or blown, however you want to see it, which is quite a nice touch, because then we know that there's been a lightning strike or a surge. And then on the right, we spoke about AFCI briefly earlier, but you'll see that our AFCI is well ahead of the requirements for the UL certification, such as the trip time and the arc power and the detection distance. We really are superior to the requirements, which should give you comfort for those markets where it's required. All right, so then looking at the backup, an example of a backup system. So as we mentioned, using the 5 kilowatt as an example, we can support up to 10 kVA or 10 kilowatts on the backup side. With utility, this would be constant. It wouldn't have any type of time limit. But without utility and only on battery or PV power, you would typically be able to do 10 kVA for up to 10 seconds. But normally when you're designing your system, you're not really, designing a 5 kilowatt inverter with 10 kilowatts of load. That 10-second period is so that you can start, boil the kettle, your fridge compressor might kick in and peak above the 5 kilowatts of the inverter's capacity, but you just got a little bit of headroom to work with there, which is really great. And then, of course, just a reminder that you do have the parallel feature, so that if a customer does have or realizes after installation that the system is a little bit too small, you can then add a second device, another 5 kilowatts to a 5 kilowatts, and that would give you a total of 10 kilowatts of nominal output. Then we also have the option of using the load control feature to be able to switch an ATS. For those markets that typically don't get sort of load shedding conditions, and they might not typically want the backup, their house's loads to be connected completely to the backup. You do have the option to switch the relay to move the load over from the grid to your backup supply, and this is a really nice feature for those that don't necessarily want to have it connected to the inverter permanently. So when the grid does fail, the load control can switch a relay that switches the backup circuit, or the ATS to the backup circuit, should I say. We spoke about the PV oversizing earlier. Here's the visual representation of this. We've used the 5 kilowatts in this example again. We've got 7.5 kilowatts of PV connected to the inverter, and you'll see that all of that 7.5 kilowatts can be utilized at any given point. This is not something that's common in our industry with hybrid inverters. Typically, you have an overhead of 20 or 30%, but that's really for efficiency losses and over paneling. With this 5 kilowatt and our 7 kilowatt PV array, you can see that we're running 3 kVA to our on-grid load, which in this scenario is an aircon. We've then got a 2 kVA load going to our critical load or backup output. That's a total of 5 kVA. Typically, that's where it would stop, but we've got the benefit of being able to use the other 2.5 kilowatt to charge our batteries simultaneously. So even if you are constantly using 5 kilowatt, you would still have excess PV to now charge your batteries, which gives our system, quite a benefit and an advantage, because in essence, you've got a 7.5 kilowatt PV inverter and a 5 kilowatt backup inverter with this specific case. And then on the bottom right, we've also got a graph which shows you, a table that shows you, the 5 and 6 kilowatt next to each other. I just wanted to highlight the PV input power. So you'll note on the 6 kilowatt, we can go up to 9 kilowatts of PV. So in this example, you would run 6 kilowatts of AC power while still charging your batteries at 3 kilowatts. So really great feature, and something that is common amongst all of our hybrid inverters, for those of you who didn't know. In terms of the backup overloading, so I wanted to actually show you a visual example of how exactly this would work. So you'll note we've got a 5 kilowatt peak PV array here going into our inverter, and we've got a 10 kVA requirement from the critical load side of the inverter. And you'll note that we've got 5 kilowatts pulling from the grid to assist the inverter in outputting the full 10 kVA. So that shows you that this is something that we've tested. Our beta testing has proved successful with our customers, and we've seen the inverter at 9.5 kilowatt during on grid without any shutdowns, which I think is case in point, and really a great thing to have, because it gives you that little bit of overhead or room in the event that there is a slight peak in the load or a larger requirement. Then in terms of compatible batteries, so we've got quite a wide array of batteries. I would like to also, at this point, just remind our customers that it is extremely important that you work with our approved battery options list. This is available for download from our website. You'll see in our warranty terms it is a requirement to be using an approved battery. If there is a battery that's not approved, please reach out to the local team or local GoodWe office to try and see if it's possible. We typically work with well-known brands or local heroes in terms of batteries. If there's ever an issue, because we've got test results and we've got a relationship with the manufacturer, it typically makes it a lot easier to be able to do support on the product. If it is a battery that we don't know, then typically it does cause a bit of issues, and we don't really know how to move forward in sorting out a support or warranty case. These are the first page of examples. So I'd just like to highlight, firstly, when you are using our GoodWe Links U battery, you'll note that you are able to do both throughput energy and a BMS update. So when you are using the GoodWe combo, we can support the battery and inverter at once. We can, as we said, push firmware updates through to the battery. We can also diagnose the full system, which is quite beneficial in my opinion. We have the same with the LG Resu range. It's one of the first batteries that we started working with. And then, you guys should know these brands fairly well. BYD, I specifically mentioned the Flex Lite as it is quite a competitive product. And it also allows up to 320 kilowatt hour paralleling. So massive, massive system. We've also got Pylon Tech, Force L1, L2, the Dynas Power Box. And there are some other models that you would see on our approved battery options list. Then some other sort of options. So we've got the Solar MD storage device, Freedom One, Blue Nova, Weco has recently joined our approved list, and then UZ Energy. I've listed again some examples, but there are others that you could refer to in the approved battery list. It's quite a detailed list. I think it's about 7 or 8 pages. And then just to show you the ESG2, one of our beta installations, some examples. It's always nice to be able to refer back to this and see exactly how the system looks. This is a 6 kilowatt ESG2, which has a BYD Flex Lite 5.4 kilowatt hour, if I'm not mistaken, connected to it. You'll see on the top left, there's 2 DB board pictures. The left is the before and the right is the after. This was a really, really old house with a very, old DB board. You'll see the switches are quite large, the breakers rather, and for this installation, the entire DB board was replaced with modern breakers, so it takes up a lot less space. And then you'll see in the middle of the second picture that the GoodWe energy meter is installed there. Then looking to the bottom, you've got the ESG2 product, and what I wanted to highlight was just the simplicity of the design. You'll note that we don't use LCD screens on our products. There's a lot of research that shows that those are most likely the first points of failure on our product. What we have is LEDs, which are typically a lot longer lasting. And it really just gives you a status update. So you've got a system light, you've got a comms light, you've got a grid light, and then you've got your battery state of charge indicator. And each one of those lights can change color or it can flash a certain way to give you an idea of what exactly is happening. For example, the grid light, if there is a grid failure, the light changes from green to orange. So without having to log into your monitoring system, you can at a glance note that the grid is off and you need to maybe be conscious of not running your batteries down too quickly. You also get the state of charge battery light, which I think is a nice touch because it gives you four quadrants, I guess. Each one of them represents 25% of the battery's capacity. And typically it will flash a certain way if it's charging, and then flash a certain way if it's discharging. And then on the right, we've just got an overall picture. You'll see that you've got, your BMS above the battery. You've got your DC, battery breaker or protection, as well as conduits. And you've got two separate conduits, which is one's for AC and one's for DC, which is a requirement in South Africa for installing of a system. But really a neat installation overall. And, if you would like to get some feedback on how that installation went, or when you do install your first one, please reach out to us. We'd be more than happy to support on that. All right, that's it. I've put the sales.africa email on the screen. You're welcome to send questions or any queries to that, in terms of the product or availability or where to purchase it. But thank you very much for your time and for your attention.
Thank you, Andrew. Thank you very much. So we've now reached the section where we're going to take some audience questions. We have a couple of minutes to do so. So this is a quick reminder to the audience. You can submit any questions you would like Andrew to answer in the questions tab on your screen. But first, Andrew, I think I'd just like to ask, so what would you say sets the ESG2 inverter apart from other hybrid inverters in the market at the moment?
Look, it's typically working for GoodWe. It's easy to say it's the sort of greatest product out there, but I really do feel that GoodWe sort of pioneered the hybrid inverter in the global context, and this product takes that a step further by just adding really exciting features. Typically when you look at an inverter like the ESG2, it offers two benefits. The one is redundancy or peace of mind in terms of having a backup supply for those markets where grid stability is an issue, but also at the same time it's an investment. It's not a product that you would that you just spend money on and not get some type of return from, and that's because it saves money by prioritizing renewable energy, and at the same time you also, for markets where you can export, you can get the benefit of exporting power to get paid for that. But yeah, the main feature I would say is the smart load control. We're one of the pioneers in that space, and I think it's so important because whenever somebody's installing or looking at a residential system, the first point of call should always be, what can we do to try and reduce the load within this home? And whether it's changing the heat pump to a gas geyser or solar geyser, or typically with our system, you could also switch loads intelligently to make sure that they fall during your peak sun hours. And but definitely an exciting product. We can't wait to see you guys install and hear your experiences.
Thank you for that, Andrew. So I've got a question coming in, which is about which is the best market, or which market is the inverter most suitable for?
Definitely residential. Typically single phase systems don't really carry over into commercial. I know that with the with some sort of commercial systems could be single phase, in which case they might fit that requirement, but typically it would be for residential, because of the sizing and obviously the fact that it runs single phase.
Thank you very much. So then also, Andrew, if you could remind us again on the new features that were added in this Generation 2 device, that would be good.
Yeah, thanks. I mean, it's always good to summarize. I know there's a lot of information that we've gone through in the last 30, 40 minutes. So the first is your parallel feature. So as I mentioned, you can connect up to 3 devices. In theory, you could do up to 18 devices. But if you are wanting to do more than 3, then we'll probably use that as a test case. Typically, you wouldn't go larger than 18 kilowatts on single phase anyway. And then, that's one. The second would be the the load control, but at the same time speaking about the generator control. That feature can be used at the same time. So it would be two separate relays that switch either the generator on or off, or switch a load on and off. And I think that's quite nice, because you sort of taking a system that's typically not smart and making it smart so that it control a load to make sure you maximize savings.
Thank you very much for that answer, Andrew. Unfortunately, everyone, that's all we have time for today. This is just a little reminder from me that the webinar will be available on demand shortly via PV Tech. Thank you once again to Andrew for taking the time to speak to us, and indeed to our audience for your attention. The next PV Tech Tech Talk webinar will be on the 2nd of November, and there's more detail of that to be released shortly. But thanks again for attending. We all hope to see you next time.
Thank you.
Thank you, Andrew.